All right, get ready, because today we're diving headfirst into a galactic collision.
A cosmic showdown, 114 million light years away.
Exactly. And we've got front row seats, thanks to some incredible images.
Not just from one telescope either.
We're talking Hubble and the James Webb Space Telescope, both capturing this incredible event.
And they each bring something different to the table,
And
right?
absolutely, it's like seeing two different sets of eyes.
Like having superpowers, one for visible and ultraviolet light and the other for infrared.
So let's set the stage. We've got these two galaxies, right? NGC 2207 and IC 2163.
Catchy names for sure.
Well, astronomers aren't always the best at branding.
But these galaxies, they're huge. One's the size of our Milky Way and the other even bigger.
Yeah, and they're not just sitting there politely.
No, they're locked in this gravitational dance, swirling around each other.
And you can see the effects of that dance in the images. The spiral arms are all distorted, stretched out like taffy.
Those are called tidal extensions. They're like ghostly tendrils reaching between the galaxies.
Exactly. It really gives you a sense of the immense power of gravity, right?
Oh, absolutely. Over millions and millions of years, gravity can warp and sculpt entire galaxies, just like we see here.
And all that warping and squeezing, it triggers something pretty spectacular.
Starbirth.
Boom! Cosmic baby boom. And you can see this in action, especially in the Hubble image. There are these vibrant blue clusters scattered throughout the galaxies,
Those are regions where stars are forming at an insane rate.
like a cosmic fireworks display.
Exactly. Hubble captures those hot, young stars perfectly because they shine so brightly in visible and ultraviolet light.
But then we switch to the Webb image, and those same regions, they're glowing red.
That's because Webb is seeing something different. It's detecting the heat coming from the dust surrounding those newborn stars.
So it's like Hubble shows us the babies, and Webb shows us the nursery.
It's a perfect analogy, and it highlights how important it is to observe the universe in different kinds of light. Each wavelength reveals something unique.
So we've got this beautiful story of creation unfolding, but it's not the whole story, is it?
Right. There's destruction, too. It's part of the cycle.
I'm looking at these red lines snaking through both images. They're kind of ominous looking.
Now, those are likely shock waves from supernova explosions.
So these are the after effects of stars dying, going out with a bang.
Exactly. Massive stars live fast and die young, ending in these incredibly powerful explosions called supernovae.
And those explosions, they don't just fade away quietly, do they?
No, they send shock waves rippling through space. And those shock waves can, in turn, trigger the birth of new stars.
So it's like out of destruction comes new life. That's pretty profound.
It's one of the most fascinating things about astronomy. The universe is constantly evolving, with creation and destruction happening side by side.
Okay, there's one area in these images that's really caught my eye. It's labeled I. In the Hubble image, it looks pretty quiet, but in the Webb image, it's blazing.
That's where Webb's infrared vision really gives us the edge. That region, it's actually the most active star-forming region in the whole system.
Wow, so it's like a hidden treasure.
Exactly. It's shrouded in dust, which blocks visible light, but infrared light can penetrate that dust, revealing what's going on inside.
So Hubble shows us a seemingly quiet spot, and Webb pulls back the curtain, revealing a starburst party.
It's a great example of how these two telescopes work together to give us a complete picture.
So we've got this incredible interplay of gravity, starbirth, supernovae, dust, all shaping these galaxies. But this dance they're doing, it won't last forever, will it?
No, it won't. In a few million years, these galaxies will merge completely, becoming a single larger galaxy.
What happens during a galactic merger? That sounds pretty intense.
It is. Think even more intense bursts of star formation, the formation of long tails of stars and gas stretching out from the merging galaxies. It's a wild ride.
And it makes you realize that our own galaxy, the Milky Way, it's not just sitting still either.
No, it's on a collision course with the Andromeda Galaxy.
Talk about a cosmic fender bender.
Well, it won't happen for billions of years, but it's definitely in our future. And by studying these colliding galaxies, we can get a preview of what might happen when our own galaxy goes through a similar event.
That's a pretty mind-blowing thought to end on. We've seen stellar nurseries, supernova remnants, hidden starburst regions, all within this interacting galaxy pair.
And it just scratches the surface of what's out there. Every time we look deeper into space, we find something new and amazing.
And who knows what other secrets these telescopes will uncover in the future.
I can't wait to find out.
Well said. Until next time, keep looking up.
Always.